is how do you draw the image of a figure under a reflection? And you have 3 I can statements that are our focus for this lesson. I can draw an image of a figure given a pre-image and the line of reflection. I can create the image of a figure given a rule and a pre-image. I did this to you guys twice, I think. I have the I cans twice because I copy my presentations and then edit them. I fixed the other one. I haven't fixed this one. Okay. 1 I can generate a rule and coordinate notation that describes the transformation of a pre-image to its image. And so vocabulary that we need for this lesson is basically reflection, right? And if you think about a mirror, your mirror image, it's kind of the same thing. It's a transformation across a line called the line of reflection. Okay, the line of reflection is the perpendicular bisector of each segment joining a point and its image. The line of reflection can be defined by an equation or by 2 points it passes through. A reflection is a transformation that acts like a mirror. It swaps all pairs of points that are on exactly opposite sides of the line of reflection. Your line of reflection can be any line in the coordinate plane. For us, though, we're not going to look at any line. Okay, the ones that are most important would be the y-axis and the x-axis. And so in this picture right here, we have triangle, the pre-image, triangle ABC, which is the neon green one, and then its image, its reflection, is A prime, B prime, C prime. It's the lighter green triangle. And it's being reflected across a line of reflection. That line of reflection is right here, this vertical line. And they're calling it line K in this picture. Okay? So this is just a very generic picture that shows you how you would reflect an image across any line. And this line can be anything. But we're going to focus on it when it's typically the y-axis or the x-axis, or even y equals x, or y equals negative x. All right, so this is an interactive slide for you. Before I turn you guys over to just working on these, you're gonna first, on this one, identify a reflection. So basically, is it a mirror image? The dashed black line, that's your line of reflection. And so does that show you a mirror image? So like if you look at the first one, you have the 2 lightning bolts, and here's your line of reflection. Another way to think about it, as if it was a piece of paper, okay, and that dashed line is on there. Get a marker so you can actually see this. So you have your picture with whatever it is. All of them have this dashed line somehow, right? If you were to fold your paper, would those 2 images match up perfectly? That's what you kind of have to visualize as you're trying to figure out if it is a mirror image. So imagine folding the image on the dotted line, and then would it create the same picture matched up? Would it be exactly the same as matched? And if it does, it's a reflection. If it doesn't, it is not a reflection. So you're just going to go through, and it's a drawing slide. So you would be able to just put a little mark on each box that would show if you think it is a reflection or not. And I'm going to give you some time to do this one right now. Let's see, I have lots of responses. You guys are doing a good job. So I like how some of you guys are taking different approaches to marking the ones that are. Some are being very creative. Some of you are marking out with like a big red X, the one that is not, and that's fine. Okay. Find the reflections. So you have to imagine if you were to fold it on that dashed line, would it make? Okay, let's look at some of your responses. All right, so the yellow lightning bolts, yes, this is a reflection. Good. The moons, yes, they are a reflection. The triangles, yes, those are a reflection. And the green, those polygons are also a reflection. So it looks like this person got it spot on. Yeah, so the problem with the purple ones is that they're not the same distance from that line. So if I was to fold that image on the dotted line, they wouldn't line up perfectly. With the orange ones, it looks pretty close, but there's an angle. So like this vertex is actually much closer to the dashed line than this vertex is. So if I fold it over, it's going to be a weird overlap. The hearts, they're not even the same direction. Same thing with this blue polygon, they're not the same direction. Okay, so some of you guys did check marks, looks really nice. Little boxes, little dashes. So it looks at this person circled, I think the ones they thought were the reflection. Okay, the orange one is not a reflection. Yeah, it's just the lightning bolts, the moons, the green one, and the blue triangles. Okay, awesome. Just like with translations, there's coordinate notation, okay? The coordinate notation that we had with translations, those, we didn't have parentheses. They were like the pointy parentheses, I guess you could call it. It's called component form. It represents vectors. So that's different than what I'm showing you here. These are not vectors. These are not pointy. They're regular parentheses. So there's notation rules. You can think about it how you would reflect an image by visualizing it in your mind, like on that last slide, what would it look like if you reflect it? But there's also rules where you use the coordinates. So these are the four most common lines of reflection: the x-axis, the y-axis, the line y equals x, and the line y equals negative x. And so these are the rules that go with it. So if you had, say, a triangle, and you had the three ordered pairs that represents its vertices, and you wanted to reflect it across any one of these lines of reflection, this is what you would do to each ordered pair. So to go across the x-axis, you would take your ordered pair, and you would change the sign of the y-coordinate. And that would then, when you replot it, it would give you your image reflected across the x-axis. For reflecting across the y-axis, all you have to do is change the sign of your x-coordinate. So these two are really simple. You just, if you're reflecting across the x, change the sign of the y. If you're reflecting across the y, change the sign of the x. Now, when you reflect across the line y equals x, and if you forgot what that looks like, this marker is dying. This is not my marker. This is my kid's marker. I'll use a highlighter. Okay, so this is the graph of the line y equals x. So if we're reflecting across this line, the rules in our presentation, what we have to do is actually take x and y and change their order. So if you had the 0.23, it would change into the 0.32. We change the order. If you wanted to reflect across the line y equals x, negative x, and if you don't remember what that one is, y equals negative x is the opposite direction. Okay, if I wanted to reflect a figure across the line y equals negative x, that's the trickiest of the rules. It's the last one. you have to take your X and your Y, change the order, and change both their signs. Okay? So these are the coordinate rules. What you're going to do now is I'm going to kind of turn you loose. You have a video on how to draw a reflection. You have a interactive slide on drawing a reflection. You have another interactive slide on reflecting a figure. You have another little video determining the line of reflection. You have an activity where you're going to determine the line of reflection. Line of reflection could be any line. This is another one, determining the line of reflection. And then this is an example where they're giving you 3 ordered pairs, a line of reflection, and they're taking the ordered pairs and performing the coordinate notation. So when you go over the y-axis, the rule is to take your x coordinate and change its sign. So 1, 2 becomes negative 1, 2. 1, 4 becomes negative 1, 4. 3, 3 becomes negative 3, 3. And then showing you what it looks like when you graph it. And so the image kind of helps you visualize that it is, in fact, the y-axis is your vertical axis. It's reflecting over it. If you folded this picture on the y-axis, these 2 triangles would match up perfectly. And then you're going to try that on the last slide. All right. So what I'm going to do for you right now is go ahead and put it in student paste. You're going to come back and, well, you can actually start on any slide you want to. That's the nice thing about student paste. You can go all the way back to the vocabulary, the I can statements. You can look at these coordinate notation rules. All right, but if you want to start here, this is where we left off together, is slide 5. And you will have until (9:50). Turn it back to teacher mode, and we're going to go over this, and then when we're done going over it, I'll turn it back to student mode and you can go back into it. So for slide 6, it said draw reflection, plot the image of point A under a reflection across line L. And so this is an example that works. This works. They're showing their work with this little like counting how many away. That's fine. This works. They're showing the process. That's fine. That's good. I really like this one because not only did they do it correctly, they also labeled it A prime, which is really nice. Okay, some of you guys put a line drawing it, and if I could find someone that did that. No, they erased it. Okay, that's good. Yeah, if you draw the line connecting the 2 A's, that's not exactly what you want to do here. So I'm not really understanding if you're trying to show me your thought process or if you're trying to draw lines. Okay, so if you're showing me your thought process, it's okay, but typically this is exactly what you want right there. All right, and then slide 7, I have some really good responses. So you had to plot the points, connect the figure, and then draw in the line of reflection. So I don't think anyone drew in the line of reflection, but it's the x-axis, they tell you right here, which is here. And if you think about folding this image on the x-axis, these 2 rectangles would line up perfectly. So that is a great reflection. The points are accurate. This person went as far as to try and label them, which is really great. Okay, this is good. This is good. So there's a lot of good responses here. Okay, you did a good job on this one. And then for 9, draw in the line of reflection. Okay, and so this works, right? Typically lines have those little arrows at the end though, so you do want to include those. Maybe it's, no, it's a draw slide. I don't know why it's only showing me 1. It's weird, because it says there's 11. Here's another one, draw in the line of reflection, show responses. So there's a great line of reflection. I don't know if it's overlapping everyone's work because it's only showing me 1 response right now, which is strange. Okay, this one, not a lot of us got to it or we started it, but if you didn't get the rule correct in this first step here, then it kind of messes up your work altogether. So the rule, because you have to figure out what is your line of reflection, it's y equals x. So if you come all the way back to slide 4, right here, reflection across the line y equals x, that's where you take your ordered pair x, y. That's all you had to do. And so that one I do want to work out with you. And I can do that by going back to it. This is a new way I'm going to try showing this. So hide responses. I'm going to share a different tab with you. Oh my goodness. I hope I'm doing this right. Okay, so yes, you can see this. So the rule, we got to make sure we get the rule correct, which is, and you know, if your pencil or your pen is too thick, you can even type. You could type on the slide. Okay, so nope. The rule here is to take x, y, and change it into y. X. X. Okay, so all you have to do is change the order. So maybe I'll just try using the pencil tool next. 2, 0 will then become 0. Yeah, see, that's way too thick. Oh, there it is. There's the size tool. So I'm going to do erase. This becomes 0, 2. 2, 2, when you switch it around, still 2, 2. 5, 2, when you switch it around, you get 2, 5. 5, 1 becomes 1, 5. Okay, so these are my ordered pairs that I would then come over and graph. It says graph the pre-image, okay, and then also graph the image and which quadrant will it lie in. So the pre-image is, we'll use a different color. So the pre-image is these. Wait, not all of those. See, this didn't let me do the little undo. It's these 4 points. So 2, 0, 2, 2, 5, 2, and 5, 1. 5, 1. Did I do that right? So it's not a rectangle. So 2, 0, 2, 2, 5, 2, and 5, 1. Yeah, so this is some odd shaped. If I connect the, looks like that. And now if I do its reflection over the line y equals x, and the line y equals x, let me just put it in for you. This line is right here. That is the line y equals x. Okay, and so purple, my 4 vertices are 0, 2, 2, 2, 2, 5, and 1, 5. So if I connect them here. So when you have an odd looking polygon and you're trying to reflect it, sometimes it's really useful to use the rule, whereas maybe on a problem like you had, wow, look at that. That is creepy. Okay. So on, I could do this. I'm pretty sure I can find my own work. Here it is. Okay, so that's probably a lot easier to see. So for this one, using this rule makes it a lot easier to think about it. If I fold this paper on this red line, these two images would match up. Whereas on a problem like, and I probably just went too far. No, I didn't. It's here. This one. Aha. Go back. Right here. So on this one, you know, the rule of reflecting over the x-axis, where you know, you take x, y, and then you rewrite it with a negative y coordinate. Maybe that's more work and it's easier just to do it visually. You know, for me, it's easier to plot these and say, this is my line of reflection. Well, this point goes here, this point goes here, this point goes there, you know, and just do it that way. But it's really up to you what makes more sense, okay? So if you prefer the coordinate way or you prefer just visually doing it, you know, one way could be beneficial, more beneficial to you. On your test, we're probably only going to be doing reflections over the x-axis or the y-axis, right? So that would be these rules. Where did it go? Yeah. So x-axis or y-axis, it would be these two rules. So you might be asked to, you know, write the coordinates out, but maybe doing the picture first and then going back and getting your coordinates might be easier. I don't know. So we'll have to get some more practice with this. But yeah, that's today's lesson. You guys are all done. And if you have any questions, I'll be on the meet. Otherwise, free to go. I'll turn back to student paste.